Welcome back to this video, dear students. Welcome to the channel Byte by Byte, where we are breaking down all the difficult concepts that a particular student might face when it comes to advanced level computer science 795. Today, we are dealing with an important concept under trees, which is traversing a binary tree. This traversing a binary tree, that is binary tree traversal, it is a process of visiting each node in the tree exactly once in a systematic way. There are different algorithms for tree traversals. These algorithms differ in the order in which the nodes are visited. Three common algorithms for traversing trees are pre-order, post-order, and the in-order. Each method has specific uses. So for now, we are going to look at these three different types of traversals. And since you are in one of the best channels when it comes to advanced level computer science 795, there are two easy methods to traverse a binary tree. In this video, we are going to look at one of those methods, and in the next video, you are going to be astonished by the second method. Let us proceed in describing these different traversal type. Pre-order traversal. This traversal visits the node in the order root, left, right. To traverse a non-empty binary tree in pre-order, the following operations are performed recursively at each node. The algorithm works by visiting the root node, traversing the left subtree, and finally traversing the right subtree. In order traversal. This traversal visits the node in the order left, root, right. To traverse a non-empty binary tree in order, the following operations are performed recursively at each node. The algorithm works by traversing the left subtree, visiting the root node, and finally traversing the right subtree. And lastly, we have the post-order traversal. And this traversal visits the node in the order left, right, root. The algorithm works by traversing the left subtree, visiting the root node, and finally traversing the right subtree. No error. This is number one. We traverse the left subtree, we traverse the right subtree, and finally we visit the root node. That is what we have. And now you might be confused in pre-order, root left right, in order, left root right, post order, left right root. Let me just give you an easy way to specifically and easily understand how to come out with a formula for each of these traversals. To summarize, let us consider root to be delta, let us consider L for the left and right to be R. Then the pre, in, and post order can be seen as a 3 by 3 matrix. Let me explain. This is what we have. So guys, put in mind that pre is the first, in the second, and post is the last, which is very easy because pre means before, post means after, then in, the present. That's what we have. And now we can see them as a 3 by 3 matrix whereby the root is the leading diagonal, as you can see. Then the left takes the center of the first row and then takes the whole of the left, as you can see. That's what we have. And finally, we fill the rest with the right. That is what we are having this way, and that is how you can easily understand the shortcut for the pre, the in, and the post order traversal. Let us proceed to example. Determine the pre, in, and post order traversal of the following trees. So these are the three. We have tree 1, 2, and 3. Let us proceed. Solution. For tree 1, the pre-order is going to be what? 28, 27, 39. So easy. Pre-order, root, left, right. As you can see, dear student, root, left, right. In order is left, root, right. So what am I going to have? Left, root, right. So that is my in order. The left, the root, the right. And then the post order is left, right, root. That is what we have for post order. Left, right, root. As easy as that. So this is the simplest non-empty binary tree that you can be given. So this was just for you to understand what we mean by left root right, left right root, and the other. Now let us proceed to tree 2. What do we get? For the pre-order, we are starting with the root. So this is our root here, 45, as you can see. From the root, where do I go to? I go to the left, and my left is 39. Are we there? Let us proceed. Root, then left. After visiting the left, I need to visit the right. Are we there? And now we realize that the right of this root is another tree. That is why we say the operations are performed recursively. So now, from the root to the left, we move to the right. This is another subtree. And now this will be evaluated again as in pre-order. That is the root first of all, then the left, and finally the right. So this is the pre-order of the tree. Root, left. When you come and you meet in another root, you evaluate it back again. Root, left, right. When it comes down to in order says left, root, right. So in order, left. So when I come here, this is my root, but I'm not starting with the root in order. I start with the left, which is 39, as you can see. So now after the left, where do I go to? The root, which is 45. When I come now to the right of this root, you realize that it is another binary tree. And for this, I repeat the same step again, whereby this is the root. I start with the left, which is 54. Then I take the root, which is 78. And finally, the right, which is 79. We move now to the post order. And the post order says left, then right, then root. When you come here, this is my root. Where is my left? 39. As you can see, after 39 now, I move to the right. But this right is another tree with this as root. And this being the root, this is the left, 54. After the left, where do I visit? The right, 79. So I visited the left, I visited the right. So I move now to the root, which is 78. And you realize that for this one now, I visited the left, I visited the right. So I move to the root, which is 45. And that is why the post-order traversal of tree 2 is 39, 54, 79, 78, 45. We proceed to tree 3, which is a little bit complex. Yes, tree 3. This is my root, and pre-order says root, left, right, as you can see. So what do I have? My root, 15. Then I move to the left, and you see that it is another root because it has children. I still take the root because in pre, I start with the root. So my root, 5. From the root now, I take the left, 3. I'm done with the root. I'm done with the left. Now I come to the right. And this right is another 3, as you can see. And I take it as a 3. So I start with the root again, 12. I come to the left, it is a root. I still take the root. I come to the left, it is another root. I take the root again. But now after taking this root, I'm supposed to take the left, but there is nothing on the left. So I move now to the right, 7. So I visited the root, left, right. I'm done with this one. I'm here now. Root left has been visited, so the right, 13. As you can see, root left has been visited. Root left, right has been visited. Root has been visited. I have visited the left subtree already, so I come to this level now. This is a root, 16. It does not have a left child, so I move to the right. But this right is another tree, whereby I have my root, 20, then the left, 18, and finally the right, 23. Let us proceed to in order, which is a little bit complicated. Pay attention and let's focus. For in order, I am starting with the left, and this is the root. When you come to the left, it is another root. You come to his left, that's what we have. So in order, we are starting with 3 because this is root. The left is another root. We take the left. When you are doing these different ones, when you move on a root, if it has children, you consider the node as a root again. If you move and the node has children, you consider it again as a root. That is why in order, since you are starting with the left, this is a root, so I must take his left. This is a root again because it has children, so I may consider his left, which is 3. After taking 3 now, I move to the root because in order, after left, I have my root. So my left is okay, 3. I take the root now, which is 5. When you come here, it is a root. And if I have a root, I must start with the left. When I come to the left, it's another root. When I come to the left, it is another root because it has a child. But now at this level, what is the left of 6? There is no left. So I come back to the root because in order, after left, it is root. So this man does not have a left. So I take the root, which is 6. Then the right, 7. You see that all this was the left of 10. And since I'm done with the left, I take the root, which is 10. All this was the left of 12. I'm done with the left. I take the root, 12. After the root, the right, which is 13. And all this was the height of 5. So you see that I am done with left, right, and root left, right, as you can see. And now all this was the left of 15. And after the left, I take the root, which is 15 itself. Now I must visit this right one. This is a root. No, I start with the left. There is no left. So I take the root, which is 16. When I go to the right, it is a root. So I take the left first, which is 18, then the root, which is 20, and finally the right, which is 23. We move now to post order. In post order, we are starting with the left, and this is the root. So the left, it's another root. I take the left. So post order starts with 3. After the left, what am I supposed to take? The right, and it is another root. So I must take the left first of all, which is a root. I take the left first of all, which is still a root. But now this root does not have a left. After left, where do I go to? The right. So I visit the right, which is 7. Left, right, I move to the root, which is 6. All this was the left of 10. There is no right, so I move to the root, which is 10. All this was the left of 12. After the left, I take the right, which is 13. Left, right, then root, which is 12. All this was the height of 5. So I did the left, I did the right. Now it is the root, which is 5. All this is the left of 15. And after the left in post order, I must visit the right. When I come to the right child of 15, it is a root because it has children. It does not have a left, but it has a right. But the right is still a root. So I must consider the left first of all, which is 18. Then I consider the right, which is 23. Left, right, then I take the root, which is 20. Left, which was empty, right, I'm done. Then the root, 16, and I've done the left of 15. I did the right of 15, so I take down the root, which is 15 itself, and that is the post order traversal of tree number 3. So guys, that is how traversing a binary tree is done. When you have a binary tree where the level is already more than 2, it is advisable to pay attention and to carefully understand how the traversal is supposed to be done, and this eases your work, this matrix, dear students. Thanks for watching this video. Do not forget to like, to subscribe, and to share to increase our community, and don't forget to drop a comment in case this different order, in case you have a particular problem with any type of tree traversal type. In the next video, we are going to introduce a smooth type of traversing a binary tree, which I'm sure will be understood by all. Thanks and see you in the next video.